Hey, hello everyone, thanks for coming along. The title of my talk I'm giving today is called Getting Fat. It's some tips and tricks for when you're building a single page application. If anyone went to Andre's talk just before, you would have seen some really good reasons to use a single page application, some really good tips there. Hopefully I'll be able to supplement that with some of my own ideas. So first of all, about me. My name's Nick Fisher. If you want to tweet angry things about how JavaScript is taking over your Ruby Python conference, Spajos is my Twitter handle. I'm a front-end engineer because, you can't see. I've got rounded borders on my slides, so you can tell that. This isn't a photo of me. The reason I don't have a photo of me is, first of all, you can see me. And if you Google for Nick Fisher, you find an author who wrote a book about kissing and living with a willy. So that's not me, so I think I'll just stick to Borat right now. That's probably the safest thing. You might tell from my accent I'm Australian, but I'm living in Berlin and I'm working for a company called Soundcloud. So very briefly about Soundcloud, we're the world's leading audio sharing platform. We allow anyone to upload music they've written or recorded, or sounds they've recorded, and share them with the world. Currently we have probably over 25 million users. Last year we decided to redesign our website and build it again completely from scratch. The old website was starting to show a few signs of aging, both in terms of its design and the functionality. And in the years since it was originally designed, the browsers and devices that everyone has have improved quite a lot, and we really weren't taking advantage of that yet. So today we have what we call the next Soundcloud. This is in private beta right now. However, we'll be hoping to launch later this year. A little bit briefly about it, it's a single page application. It's written entirely in JavaScript. There's no backend for it whatsoever. The way that we get our data in is to use our public API, which has been there for some time. So it's actually just an entirely new client application for our API. So as Andre spoke about, single page applications have got a lot of really useful and good benefits. First of all, for your users, they'll see faster navigation, more responsive interaction, and so on. And for your backend as well, it's really great to offload the rendering and so on to what essentially is the world's biggest supercomputer, which is everyone else. So that's really handy. But it doesn't come completely easily. There are some challenges, and so what I'll be talking about today is just a couple of those challenges and what we've done to address them. So the first point is how you manage dependencies when you're building a really large JavaScript application. How you manage your CSS when you're building these sort of things. And then finally, how you actually package all of this code together to send it over the wire to actually run it in a browser. So first of all, with dependencies, it's probably a bit funny to most Ruby or Python developers, since this is something that's baked into almost every other language. But due to the nature of JavaScript, it doesn't have any built-in module systems, importing, requiring. And because no one has really been using JavaScript for large applications up until a couple of years ago, it's still something that hasn't totally been worked out yet. The status quo, at least up until 1 or 2 years ago, was that the way that you would, first of all, you would split your code up into your application into many files, obviously. But then you had to actually share those blocks of code with each other. And the way that this would be done would be via creating a global namespace object. So for example here, you might, at the start of every file, define an object, let's call it SC, and initialize that. And then into that file, you would then attach whatever you need to do in this module. So here we create the new sound model and attach it to the global object. And then once you've got that, you've got dozens or hundreds of files, you need to actually run that in the browser. And so then your HTML file looks a little something like that. This is actual code from our mobile site, but it's embarrassing. Sorry? Yeah. Yeah, so obviously you can see some problems immediately with this. The most glaring one is that if you actually served this to a browser, then it would be making hundreds and hundreds and hundreds of HTTP requests back to the server to fetch each of those files. This is something that's been solved a long time ago. It's very standard practice to combine these files together, and you avoid that problem. However, there still are some big problems there. So we can combine that and avoid that, but you still have to load everything. Because it's not actually very clear what modules are needed for any other module, your only real option is to just load all of it. In the example from before, the SC sound object required SC model to be there, but that wasn't actually stated anywhere. The only way that you can actually order those, that has to be ordered correctly, and you have to do that manually. So when you've got this big list here, you have to make sure that the model is before the sound. In this example, it's fairly simple, but in real life, when you introduce a circular dependency, tracking that down and solving it is an absolute nightmare. And finally, it's not a huge point, but there's no correlation between the name of a module and where you can find it on the file system. So unless you've actually got a really good name structure set up, often you end up just grepping through your entire directory to find where a module is defined. So the solution to this is to use modular code. These days, the most common library, the most popular one is called RuPy.js, and it uses a syntax for defining modules called AMD, which is asynchronous module definition. RuPy.js is, yeah, I already said that, sorry. But we're not actually using AMD. What we do instead is that we write our code in a different syntax called CommonJS and serve it as AMD. CommonJS is the module style that's used by Node.js, and it runs on the server. However, it doesn't actually run in the browser, so it has to be converted at the build time. So I'll give you an example of what those might look like. So this is what a module might look like in our code. That at the top we just do sound equals require model sound, URL equals require liburl, and then to export whatever we need to export in whatever this file is, we attach it to this module.exports, or we assign it to module.exports. And then whatever requires this file gets that object. So that's what we write, but this is what it actually turns into in AMD. So everything starts with a call to define. The first parameter to it is the name of the file, and this is derived from its path on the file system. So this would be path/to/mymodule.js. Then you have to write out the dependencies of this module. So this is so that the loader can make sure that those dependencies are there, so that when you're actually running your code, importing those things is synchronous. Then you have a wrapper function, which is given some helper methods as arguments, and then you actually have your real code. So I hope that looking at that, you can kind of see why we don't write directly in AMD style. It's really tedious to write that out. It's a lot of boilerplate. You have to write your dependencies have to come in twice, and that can lead to errors, and it's just not very much fun. And also, it's really, really simple just to automate this. Like you can just write a program which finds those require statements, wrap all your code, and have it done with. It's very simple. Another benefit, though, is that if you're doing any work with Node.js, so we have our build system and a local development server written in Node.js. They can access our front-end files, so we can use that to share configuration between the front and the back end, or the front end, the runtime and the build time, and that saves us duplicating a lot of code. The other thing that you can do when you explicitly state all of your dependencies like this is that you can build sort of tools around it. So for example, you can put together dependency graphs. These things can be really helpful. I'm sure everyone would have seen one before. Especially useful if you accidentally introduce a circular dependency into your code. So when we develop, we have a Node.js server that runs locally. So into that, I built a small module which automatically generates these on the fly. So I'll see if I can show that to you. Oh, it's a bit... Anyway, you can get the idea there. So this is the dependency graph for the lib helpers title helper module. So you can see that it only requires 2 modules, event bus and config, but then they have their own trees underneath them. The real benefit of this is that, get rid of that one. If I was doing some code, so this is in the support, I'll go back here. So where's my mouse? Down here, the support library. If I were to be doing some code editing in here and decide, hey, I need to reference the title helper for some reason. So if I add that code there, save that, and then run my application, it won't work. And I can come here, refresh this page, and then we can see these up arrows. So the graph is structured vertically so that if there's any arrows pointing up, then you can tell that's a circular reference. So we can see the cycle there goes through the event bus, persistent store, and so on. And then that can help you, it doesn't help you solve it, but it can help you track it down. So that's the first step, which is quite important usually. And, all right, cool. So the module that we've written isn't open sourced. It's kind of has some assumptions about our application built into it, but if you are interested in something like this, there's an open source version on GitHub, which does essentially the same thing. I haven't used it myself, but it looks very good. So going back to the problems that we spoke about before, when you're using this modular approach to code, you can get rid of all of that crap and you replace it with a single call to the required JS library and tell it the starting point. So like a bootstrap or your application file, which then loads all of the other modules that you actually need. So because of that, you don't actually need to load everything anymore. You just define what you need, and then those dependencies actually define what files you actually need to load into the browser. In practice, it's actually not quite as simple as that, because up until your code gets to a certain size, it's still actually more efficient to package it all together and send it all to the browser. However, once you start getting to over 1 megabyte of code or so, that's so much that you probably don't want to be inflicting that on your users on every initial page load. And if you have your code structured this way, that means that you do have the tools to say, okay, let's build a package that's just the code we need for the home page, and then asynchronously load in all of the other files that you need later on. Ordering done manually is no longer a problem because they all define what has to be there before they can run. And the modules are all named after their location on the disk, so it's really simple to jump between modules. Where are we? All right, cool. So this takes us over to CSS now. So not quite sure, like how many front-end developers or people who have worked on front-end do we have here? Anyone? Yeah, okay. CSS, yep. How do you like building large applications with CSS? Does it get good? Is it terrible? Yeah? Yeah, thank you. So in my own experience, when you're building these applications, after an amount of time, it happens to everyone that they look at this one styles.css file that they've got, and it's like 3,000 lines, and you don't know what any part does anymore, and you make one change, and then suddenly your sign-up page is broken. And even if you're using tools like Sass or less, and I would even say especially if you're using tools like Sass or less, it can get into, you can put yourself in a really bad position, and you can end up with selectors that look something like this. This is a real selector that's actually on the current soundcloud.com website now. I looked through, because we're using Sass there. I have nothing to do with it, so I can point it out. But this is an abomination. Like there's 11 different steps in this one rule. There's like 5 ID selectors. And then at the very end, it's got important, like as if there's going to be something more specific than that which overrides that rule. So you can see you can quickly get out of hand. So this is real life, scary stuff. So some of the problems with CSS, again, you usually end up just loading your entire CSS file on the first page load. And like I was saying, sometimes it gets up to 3,000 lines or more. Some sites, I think Soundcloud.com, the current site, has had to actually split into 2 different CSS files because Internet Explorer can't handle that many rules defined in one file. And the file size of these, you're talking like 300, 400 plus kilobytes of just CSS, which has a real impact on users. They do notice that. The fragility of some of these selectors. So with that one before, there was 11 steps there. So it's 11 places it could go wrong. If any of those IDs or classes changed, or even if you did something fairly innocuous, like just change the nesting of something or change from a span to a div, you could break things that you have no idea or it would seem completely unrelated. And the other thing is that it's slow. Like, people don't really think that much about CSS performance, but it really does matter, especially if you're targeting any mobile or tablet device. The CSS engine has to evaluate each of these rules, and the more steps there are in each rule, that means more steps it has to evaluate, and lookups to the DOM and so on. It can get quite slow. So the solution that we've come up with, first, like a very small background about the Next Soundcloud. The way that we've built our application is that we have lots of small views that kind of nest and composed of other views. So at the lowest level, we might have like a single button or a label or something like that, and that kind of gets built up out of those views. And we have one CSS file per view, right? And this is an example of what it might look like. So for one view, we'll give it a unique namespace for its CSS rules. And inside the template for that view, we use that namespace as a class on each of the elements that we want to target. So this is the CSS for our sound title, which surprisingly is the view which displays the title of a sound. And we'll have a div there with class is sound title info. When we want to style that, we just use that one class name. And we can be sure then that style won't be affected by anything else. None of the styles that we write here will leak and affect any other view. And obviously, like I was saying before, the performance is much faster. There's one thing to look up. It's a very fast lookup, and that can really help. But there was one thing extra I said in the problems of CSS, which is like loading it all at once. And what we do for that is we convert our CSS into JavaScript. So I'll just take a quick break. Okay, so the idea that led to this came from my first point about code dependencies. And when you're writing some library code, say you need to do some URL manipulation, then you require the URL library. When you're writing a view, if you want that view to actually work as you want it to work, then you need it to look right. You need the CSS to be there. So why wouldn't you just require that in the exact same way? So with that idea, we include our CSS exactly as we include any other module. We use the exact same require statements. But for this to actually work with require.js, it's expecting a JavaScript file. So what we do is in our build step, we generate a JavaScript file which defines a HTML style tag which includes the CSS text that we wrote in the CSS file. So I'll give you an example. So going on that sound CSS I showed you before, the sound title, this is what is actually sent to the browser. So we have the same define, then the name of the module. So this is its path on the disk. It has no dependencies, obviously. Then we have the wrapper function. And then here we create a style tag, assign it to the exports. So whatever requires this gets that style tag. Into the style tag, we then append a new text node, and that's the CSS that we wrote. So the way this actually works then, to actually put this into the browser, is that when that view is rendered, or when any view is rendered, it looks at the CSS files that it has required. And so it has a reference to all of these style tags. And it checks each one to see, does it have a parent node or not? If it doesn't, that means that we haven't actually added it to the document. And so then we insert it into the head. And if it does have one, that means that this view has been rendered before, or some other view has also required the CSS, and then we can just skip it because it's already there. And when we do it this way, it means that in the document, there's actually only as much CSS as you actually need. So if you think about any application at all, there will be lots of CSS that you have that most of the time is never going to be needed. So if you have like your sign-up page, you probably have some quite specific CSS for that, but a user will only ever see that once. But you're still loading it every single time they visit your site. Adding this during the rendering of the page does actually have a very small impact. There's like, we measured using Speed Tracer, it's about 3 milliseconds or so, because it has to recalculate the styles to see if these new ones affect anything else. The browsers should soon, one day, have scoped CSS styles, so that should really speed that up. But in the meantime, this insertion is done once per file per session, so it's not really a massive problem. Have any questions on that while I'm here? Yes?
How do you handle Internet Explorer limitation of 31 styles per?
Sure. So the question there was, Internet Explorer 9 has got some limitations on how many style tags you can have in the document. The code isn't exactly like that. There is a check there for Internet Explorer, and we just append into the same style tag. So that's how we handle that. IE 10 has fixed that though. So going back to the problems, everything loaded at once, no longer an issue because of this modular approach. The really specific class names means that you can very confidently edit the styles or the templates, and you can be safe that nothing else will break. And the really short selectors really help the performance. So moving on now to packaging. So, yeah, sorry. So packaging, I'll move on from that one. This is like, you've written all your code, you've got all your dependencies, modules are all going well, but we still actually need to send this to the browser, and that has to be efficient because it's really important to get the good performance on that first load. Like I said before, up until you get to a certain size, which is actually quite large, it's still probably most efficient to package all of your files into one or a couple of JavaScript files and send them always. The browser can parallelize 4 or 8 requests, but then you want to save some connections for assets and so on. But still, the most common thing is just to package it all together. But I think that, so that's the combine and minify approach. But I think that if you are a bit smart about it, you can get some extra wins there. So what we do is using the abstract syntax tree, the AST. So that's the representation of your code as the interpreter sees it. So it reads your JavaScript, converts it into sort of a tree. And by stepping through that tree and reading that, manipulating that, you can actually get some really good wins there. So the first thing we can do with that is find exactly what files our application needs. So instead of just saying, okay, package up my entire source directory, find all the JavaScript files and roll them together, you can just tell a sort of a walker to start at one point. So you give it like your application bootstrap file, and then it can recursively step through all of the dependencies and then find just the source files that you have. further from that, you can then step through, you can then read the ASTs of all of those files to see if they have any strings which reference assets and mark those ones for inclusion as well. So this means that if you have assets or files in your source directory which aren't actually included by anything, they won't be included in your deployed package. And you can also flag them as a warning for the developer that, hey, maybe you've got a typo here, or maybe you can delete these files now. So what we do for the next Soundcloud is that we have, so after we've stepped through everything, we've got all of our JavaScript, CSS, and templates. I won't go into templates, I'm running out of time, but essentially the handlebars templates which are compiled to JavaScript functions. So all of these are actually JavaScript files at this point. And we split them up into 3 different buckets. Into the first one, we put all the vendor files. So these are third-party libraries such as jQuery, underscore Backbone, Sound Manager. Templates go into the second one, and everything else falls into the last. The reason we split it like this is not completely scientific, but because we rarely change our vendor files, that means between deployments, they can stay cached on clients' browsers. The templates, because they're all generated code, there's very commonly repeated patterns there, which means that gzip can actually do a pretty good job. It saves a couple of kilobytes, not much, but it helps, and then everything else falls into the last bucket. So then we have all of our files separated, and then what we do is look at all of the files in each bucket and find the latest git char commit char for those files, and we append that into the file name. What we're not doing is doing a content hash like MD5. That would probably be simpler. However, it's actually really good to have a meaningful value there. So if you're running lots of different production environments, staging, testing, and so on, it's really good to be able to see exactly what file is deployed and be able to reference that back to your repository. And then the final step before we actually write it to disk is to minify the code. So we use a library that's called uglify.js because it's the opposite of beautifying, I guess. And out of the box, it's a really good library that does everything that you'd want from a minifier. Removes white space, codes, shortens variable names. But it actually gives you a really powerful way to do some more interesting things with the code. Don't know if I have time to go through all this. But basically, if you want to add some, this is something that we came up with, that we want to add some debugging code, so stuff that you would definitely not want to put into production at all. So we thought, okay, let's look at JavaScript preprocessors. So these borrow syntax from C, that you have comments with like a special syntax there, and the preprocessor finds those and strips out the text. But that's crap, don't do that. The reason for that is that you should, of course, be using the AST for this. This is what your code is. It's a description of a syntax tree, and to modify it, you should be modifying the tree, not these text files. So as a parallel story to this, if anyone knows Stack Overflow, you might know like the most upvoted answer on all of Stack Overflow. It was an answer to this question, which is fairly innocuous. A guy just wanted to know how to use a regex to modify his XML. And the answer came back like this. And it starts out like pretty normal, but then as it sort of goes through, like he starts descending into madness and finds like Unicode characters I've never seen before. And then ends up with, have you tried using an XML parser? So the point here is that there are tools out there that are designed specifically for inspecting and modifying these sorts of documents, and you should be using those. So very quickly, I'm running out of time. Here's an example of what we would actually write in our code now. So we'll have these constant variable names. This is just a convention that we use. It doesn't have to have any special name. So maybe for assigning the client ID depending on what environment we're running in, and if we have a debug mode flag or not. So to uglify, the first step is called mangle, and this does a few things, including shortening the variable names, And then you can also tell it constant values for certain variables. So here we would say, let's say env is production and debug mode is false. So after mangling, this is what your code would look like. So you can see it's shortened client ID in both places just to A and substituted in the constant values. The sum condition variable is global, and so it hasn't been shortened. So just explaining why that's like that. And then the next step is obviously to see if we can do any optimizations with this. So this is called squeezing. And this steps through the tree and finds any dead code or code which couldn't actually be reachable. So at this step, it would look at this and see production equals production, that's always true. And false and anything, it doesn't matter what, that's always going to be false. And so the output of your minification then is just A equals ABC. So that's some pretty good minifying if you ask me. So summing up, when you're building these large applications, if you are able to write your JavaScript in a modular way, it gives you a really good way to reason about the dependencies and tools to work with them. The same principles can be applied to CSS, and they work very nicely and got some very nice side effects with doing that. And by combining all these and using the power of AST, modifications of the AST, you can get some really good wins that helps your application get fatter a lot more efficiently. So, thank you very much. I'm not sure if we've got time for...
Now the coffee break, so we have time.
Oh, okay. I shouldn't have rushed. Does anyone have questions? Yes. So how do we do testing? We only have unit tests right now, so that we run those in the browser. Nothing particularly special there. We are looking at doing proper integration tests. That should be coming soon, but no exciting answers there, sorry. Yes?
I have a question about the CSS. Do you style every single element on the web page from scratch? You don't style anything? And
So,
if you do, don't you have any consistency problems?
Sure. So the question was, like in my examples, it really did make it look as though we style every single element from an absolute baseline. It's not the case. We do have some global styles. So we have essentially it's like our own Twitter bootstrap kind of thing. But we attach extra classes onto those. So for a button, we would have SC button, which puts some base styles on it. And if we need to modify that any further, then use the really specific targeted selectors. Is that all? Thank you very much.